Welcome to Maths with EJD. In this video, I'll be talking about Nash equilibrium in the battle of the sexes. In the one before now, I had introduced Nash equilibrium. Of course, not like introduction, because in a maybe in an earlier video we had actually talked about Nash equilibrium, which is basically that point you get into in a that you get to in a game where you have optimal payoff. You cannot improve on the payoff. That's the basic idea. So in the last video, we went a bit into it, using the prisoner's dilemma to deal with that. And here I'm looking at the battle of the sexes. I want to see how Nash equilibrium plays out in this situation. In the previous video, I also talked about the fact that Nash equilibrium can actually have, so for Nash equilibrium, right, you can have no equilibrium, you can have no equilibrium, you can have one equilibrium, okay, and you can also have two. You can have multiple. Let me just say multiple instead of even two. You can actually have multiple equilibrium, you know. So in the battle of the sexes, we are going to see an example where you can have multiple equilibrium for multiple Nash equilibrium, actually. So that's the essence of this. And by way of refreshing our minds, right? Uh, you remember that Nash equilibrium, Nash equilibrium is a point in a game where no player can improve. No player can improve their outcome. So it's like optimal payoff, optimal outcome. So no player can improve their outcome by unilaterally changing their strategy. By unilaterally changing their strategy. So it's some kind of stable state. It's a stable state. And that's the whole idea of equilibrium, right? It's a stable state where everyone is making their best decision based on what others are doing. So in the case of the prisoner's dilemma, we saw that the best decision the both players can make is to both defect. That is where they get the best payoff. Okay. So when we talk about the battle of the sexes, what exactly are we referring to? The battle of the sexes. The battle of the sexes. Okay. Now, imagine that Alice and Bob are deciding between two activities. Between two activities. Okay. Assume that Alice and Bob are husband and wife, for instance. And the two activities they have to choose from are football, which is Bob's favorite, and then there is ballet, which is Alice's favorite. Okay. So imagine their payoffs, right? Their payoffs, their payoffs depend on coordination. Coordination means that they need some kind of agreement, because it's more like they want to enjoy they want to enjoy activity together, but they have their favorites, right? So imagine that so let's have Alice here, and then we have Bob up here, for instance. Um, so imagine football and then ballet And then for Bob also we have football, and then we have ballet. So with this now, okay, this is football, right? Football. Now, see what happens if Alice chooses, okay, if Alice chooses football, the payoff is two. And if both Alice and Bob choose football, the payoff for Alice is two, and the payoff for Bob is one. Okay. And then if Alice chooses ballet and Bob chooses ballet, the both of them have it's 0-0, right? Like nobody gets anything out of that. Then if Alice chooses ballet and Bob chooses football, so it's like they're at cross purposes. So nothing in common. So they want to spend time together. So I mean, if they choose different activities, it won't work. On the other hand, if Alice chooses ballet and Bob chooses ballet also, so you know they can enjoy the activity together. In that case, because um Bob is choosing Alice's activity, right? Alice gets 1 point and Bob gets 2 points. So it's more like Bob is sacrificing for them to have the time together. So it's more like a sacrifice and he earns more points. So, and that's the basic idea of the battle of the sex. That's what the playoff looks like right there. Now, how do we find the Nash equilibrium in this case? Um, so the next thing is I want to find the Nash equilibrium. Finding the Nash equilibria, or if it, I mean, we don't know whether it is equilibria or equilibrium. So let me just say, finding the Nash equilibrium, whatever that ends up being, will be fine. So imagine if Bob chooses football, if Bob chooses football, okay, you see that Alice's best response is football, and the payoff is two. I mean, just like what we did in the previous video. So imagine if Bob chooses football, that means this is Bob choosing football right here. This is Bob choosing football right here. So, and then in that case, if Bob chooses football, it means that um, Alice has two options. If Bob chooses football, Alice can also choose football and get 2 points, or she can choose ballet and get 0 points. So because she wants the best, she would rather go for 2 points and choose football. So that's the idea in that case. So on the other hand, right, if Bob chooses ballet, two now, okay, guess I want to switch. So two, if Bob chooses ballet, so in that case, Alice's best response, Alice's best response would also be ballet. In that case, her payoff is one, which is better than zero, right? Imagine this is the situation here. If Bob chooses ballet, this is what we have. This is Bob choosing ballet. And in that case, Alice either chooses Alice either chooses football and gets uh Alice either chooses football and gets 0 points, or she chooses ballet also and gets 1 point. So in choosing ballet, she's better off with 1 point compared to 0 points. So in that case, her best bet is also to choose ballet. All right. So look at the third scenario. The third scenario is that what we do to get a Nash equilibrium is you look at the best option for each person and then combine together, and that will form your Nash equilibrium. So imagine that Bob chooses, okay, that's now we're going switching over to Alice. So if Alice chooses football, if Alice chooses football, so in that case, Bob's, okay, let's check. If Alice chooses football, now check this out. This is if Alice chooses football, right? This is Alice actually choosing football. This is Alice choosing football. So in that case, the payoffs for so um Bob can actually choose football and get 1 point, or choose ballet and get zero. Okay. So in that case, the best bet for Bob will be to choose football and get a point instead of getting no point at all. So it means that if Alice chooses football, Bob's Bob's best response is football, which ends at 1 point compared to zero. So the payoff is one. Okay. Then we have the fourth scenario. If Alice chooses ballet, if Alice chooses ballet, okay. If Alice chooses ballet now, so let's see what that looks like. This is Alice choosing ballet, okay. If Alice chooses ballet, Bob can either choose ballet also. Bob can either choose football. Sorry, Bob can choose football and get zero, or she can choose. I mean, he can choose football and get zero, or he can choose ballet and get 2 points. So we'd rather go for 2 points, right? Um, so in that case, if Alice chooses ballet, um, Bob's response, rather Bob's best response is ballet. Okay. And that gives a payoff, which is two. In that case now, so we see that the Nash equilibrium is in two places now. So here we can come and talk about the Nash equilibrium. So Nash equilibrium, or rather we have two Nash equilibria. So it's either they choose football. So Alice chooses football and Bob also chooses football. And in that case, Alice gets two and Bob also gets two. On the other hand, they can choose ballet, where Alice gets 1 point and Bob gets, oh sorry, this should be Bob gets one here because Alice is sacrificing for him by watching football. So in this other case, they can choose ballet, where Alice Alice actually gets Alice gets 1 point and Bob gets 2 points because Bob is sacrificing for Alice in this case. So in this case, we have multiple Nash equilibria. We have two Nash equilibria in this case. So what is the key takeaway in this situation? Um, what's the key takeaway here? So Nash equilibria highlights stable outcomes, but coordination coordination is essential. So in this case, they need to coordinate, like they have to agree that okay, maybe this week we go for football, next week we go for ballet. So they have to agree together in that case. That's how the relationship can work better. Nash equilibria, it highlights stable outcomes, but coordination is essential to resolve conflicts. Okay. So this concept applies to real world situations like You know, when you have to go on, when there has to be teamwork, when there are negotiations, each person is looking for what is mutually beneficial, and of course, strategic planning. And that is the place of Nash equilibrium in the battle of the sexes, where coordination is necessary to reach mutually beneficial, decisions. And that is it. So after now, I'll be going to talk about mixed strategy Nash equilibrium. So let's go ahead for that. If you have not subscribed to the channel, go ahead and do that right away. Hit the notification bell so you can get notified each time a new video is released. Comment, let me know if you want to teach a topic or solve a problem. And like and share so that more people can have access to this great and interesting content. Till I come your way again, keep playing the game of life with wisdom.